It's important to know if the surrounding soil of a community or residential property has potentially dangerous levels of lead or other toxic metals. This is of particular concern if children play on the grounds or if vegetables, herbs, or other edibles are grown in the soil. Soil surrounding older buildings frequently contain lead from simple wear and tear of pre-1978 lead-based paints. The soil beneath doors and windows can contain elevated levels of lead in the form of dust or flakes from repetitive opening and shutting. In communities that have industrial facilities, the soil surrounding even post-1978 homes can also contain toxic metals. They are carried by the wind or rain in the form of particulates from factories, especially from smokestacks. These contaminants tend to concentrate at drip lines, typically the corners where rain or snowfall washes the metals down from the roof, concentrating them in the soil beneath. Industrial pollutant metals can also enter the soil from groundwater or from waste runoff streams. Handheld XRF is an ideal tool for quickly screening soil for toxic metals. Simply place the analyzer window on the soil, press the trigger, and read the display. Test results can be seen in seconds, which help to determine the next course of action if caution or remediation is necessary. The property being screened for this video was built in the early 1800s, is in an industrial community, and is near heavily traveled roads. Some small industry is within 1 mile, there is a power plant within 5 miles, and it is within 1 mile of numerous leather factories that have been closed for several years. It's on a hill, so groundwater or runoff streams wouldn't be expected to affect the soil, but concentrated levels of lead would be expected at the drip line due to its age as well as the nearby industrial and traffic activity. The stone cover the owners placed at the drip line is being cleared to get a good measurement of the soil underneath. A plastic baggie is placed on the soil to prevent transfer from one sample to another. The analyzer window is simply placed on top of that to test directly through the baggie. The readings of the drip line soil are about 2,300 parts per million lead. As a reference, the US EPA gives a general level of 400 parts per million lead in a residential area. The owners have covered the drip line soil with stone, which helps prevent access, and, although there are no children living here and no edible plants growing, the owners may want to remediate further at some point in time. Even though the house is primarily brick and the old windows have been replaced, lead is expected to be found in the soil beneath the windows and doors because of the age of this property. As is typical in these older homes, there are wooden add-ons to the original structure. This particular home has an old well with a garden planted around it. The soil around the well will be tested because it looks like the perfect place for an historical herb garden. The leaves and pebbles need to be cleared to get a good measurement of the soil, and a plastic baggie should again be used between the analyzer window and the soil to prevent sample-to-sample transfer. The readings of the soil are about 1,000 parts per million lead. The 400 parts per million lead US EPA reference level would indicate that this is not a good place to plant edibles or an herb garden, even though it may look historically correct. To test a sample that is more representative of the soil than just the surface, it's recommended to dig up some of the soil, place it inside a baggie, and mix it up a bit. This is a more homogeneous sample and may improve accuracy and precision. In this case, the reading of the bag soil is about 1,000 parts per million lead, which is in good agreement with the simple surface measurement previously taken. To follow EPA method 6200 for field measurement of metals in soil, one should also take some of the mixture in the baggie and prepare it for lab analysis. This requires that it be dried, pulverized, and sieved to provide a homogeneous sample with a flat surface. Since XRF is non-destructive, this same sample can be sent to the lab to correlate with ICP measurements. The perimeter towards the back of the property looks like a good play area or a place to plant edibles. Leaves, weeds, and other debris need to be cleared to get a good reading of the surface soil. A plastic baggie should again be used between the analyzer window and the soil to prevent sample-to-sample transfer. The readings in the soil are about 250 parts per million lead. This is well within the 400 parts per million US EPA reference level, which would indicate that this may be the best place to plant edibles or let children play. It's always a good idea to bring a sample cup of pure silica to confirm that there's no transfer from sample to sample or to the analyzer window. No lead should be detected when measuring the pure silica. In conclusion, it's important to know if the surrounding soil of a community or residential property has potentially dangerous levels of lead or other toxic metals. This is of particular concern if children play on the grounds or if vegetables, herbs, or other edibles are grown in the soil. Handheld XRF is an ideal tool for quickly screening the soil for these toxic metals. Simply place the analyzer window on the soil, press the trigger, and read the display. Test results seen in seconds help to determine the next course of action if caution or remediation is necessary.